Hey everyone, and welcome to section 4.3. We're going to be finishing up our discussion on systems of equations with some more applications. We're going to be looking at some mixture type problems. So first up, we have a service center selling some tickets for an event. The receipts totaled $12,146, and the question is how many $12 adult tickets and how many $7 child tickets were sold. So this problem is pretty directly asking for the number of adult tickets sold and the number of child tickets sold. So we need to name those. All right. So those are our variables. We know altogether we sold 1,363 tickets. So that tells us that x plus y is equal to 1,363. And we also know the total revenue from that event. So the money coming from adult tickets would be 12 times x, and the money coming from child tickets would be 7 times y, and that together totaled 12,146. So there's my system, and what I'm going to do is solve this by substitution, because I can just subtract one of the variables in the top equation to get the other by itself. And then we go back to the other equation, make our substitution. And then we solve for y. So we get that y is equal to 842 tickets. And then to figure out how many adult tickets were sold, we just need to take our equation for x and substitute back in our solved value of y. And we get 521 adult tickets. So let's check. Everything checks out, so let's write our sentence. So 521 adult tickets and 842 child tickets were sold. All right, one last example. Okay, we need another name. Pell. So Pell is a lab assistant at his community college. He needs to make 200 milliliters of a 40% solution of sulfuric acid for an experiment. Unfortunately, the lab only has 25% and 50% solutions in the storeroom, which figures, right? Every time you need 40% solution, 25 and 50 available. Typical. But okay, so how much should Pell be mixing to get 200 milliliters of a 40% solution? Alright, so this problem is asking us what is the amount of each of the solutions, the 25 and the 50, that I have to mix together to get 200 milliliters of the 40% solution. So let's name our variables. So one thing that we know is that together the amounts should add up to 200 milliliters. But we need a second equation, and if we think for a little bit, we also know the exact number of milliliters of sulfuric acid needed for the experiment, because a 40% solution of 200 milliliters would be 80 milliliters. So we can fit that in. So that can be our second equation, the amount of actual sulfuric acid. For the milliliters of sulfuric acid coming from the 25% solution, we would take 0.25, multiply it by x. And for the amount of sulfuric acid coming from the 50% solution, we would take 0.5 and multiply it by y. So there's my system. I'm going to solve this by elimination. So I know that if I multiply the bottom equation by -2, then the y coefficients will be opposite. Then I'm going to add my two equations together. And 0.5x equals 40. So x would be equal to 80 milliliters, which means y has to be 120 milliliters. So let's check. And it checks out. The other equation also clearly checks out. So now we need a sentence. And there we have our sentence. Pell should mix 80 milliliters of the 25% solution with 120 milliliters of the 50% solution, exactly 200 milliliters of the 40% solution. And that about does it for section 4.3, and we'll be skipping the rest of chapter 4, so we're going to be moving on to chapter 5 next.